There really are no notes today. You've learned all the vocabulary you need. You've learned all the skills you need. I'm going to do a couple examples to show you how to put all that together to actually solve. And it's really important that you understand you should check your answers. Remember the term extraneous solutions? When you've done nothing wrong yet the answer doesn't work. Mathematically you get a number, but that number doesn't work when you put it back in. You have to check your answers.
That can happen?
It can happen, yeah.
Oh, I thought it was only that one lesson.
No, that can happen. And I'm going to do one today where we get an answer that doesn't work, so you can see how it happens. All right? Okay, in this first example, the problem with this equation is we have variables in our denominators, don't we? And we just did a lesson where we were adding, and to add we have to have a common denominator, and we could look at it this way, but in this problem, this is nothing more than a ratio equal to a ratio. What's that called? A proportion. And what's the rule for solving proportions? Cross multiply. And so that's all I'm going to do here. I'm going to say it's 1 times x squared minus 9 equals 6x times x minus 3. It's important if there's more than one term that you put them in parentheses so that you're multiplying all of it by that number or those numbers, not just part of it. Sometimes you'll have to FOIL. In this case we don't. We could distribute. When I distribute to 1, obviously, we just get x squared minus 9. I hope you see that. And on the other side, when I distribute 6x, what do I get?
6x squared minus 18x.
6x squared minus
18x.
18x. Good. Okay? Now, it's important now to solve a quadratic that we set it equal to 0. So I see a positive 6x squared and a positive 1x squared. So if I subtract the x squared, I get negative 9 equals 5x squared minus 18x. And then what do I do? Add 9 to both sides. So I get 0 is equal to 5x squared minus 18x plus 9, because we added 9 to get rid of the negative 9. Okay? Now we can factor. We could graph. Probably not the way we want to go, but we could graph. Or we could use quadratic formula. Or we could complete the square. All those methods we taught you to use to solve this quadratic. You want to complete the square? Oh, good. Oh, I thought you said, let's complete the square. And completing the square usually is not the easiest way to go. It's probably be my last method. It does have a good purpose, and that's why I made sure that we covered that. But it's not an easy one to deal with. That's why Mrs. Mills skipped it last spring. You didn't cover 5-7, I think it was, last spring. So anyway, this could factor. I haven't thought about it, whether it factors or not. The signs have to be the same. 15 and 3 is 18. Yeah, it certainly would factor.
Yeah.
If we want to factor it, we can factor. If we want to use quadratic formula, we can use quadratic formula. I'll show you the factor. This means the signs have to be the same as this one. So they're both negative. I have to have an x, I'm sorry, an x, not an x squared. And an x. And an x. The only way to get 5 is 5 and 1, so I'm just going to put that in. And then the question is, do I want to use 3 and 3 for 9, or do I want to use 9 and 1? And the nice thing is 3 and 3 work, so it really doesn't matter where they go. The outside 2, if I test it, 5x and negative 3 is negative 15x. And the inside 2 is negative 3x. And negative 15x and negative 3x add up to negative 18x. So it did factor. And so we can do that. I guess I'm not going to erase anything. So So that means then that 5x minus 3 is equal to 0, or x minus 3 is equal to 0. If I put this in, solve this first one here, 5x is equal to 3, so x is equal to 3/5. So if I put this one in, if I solve this one over here, x is equal to 3. All right, now we said we had to test it, check it to make sure it works. So if we go back to our original, if I put 3 in here, what happens?
Zero.
I get 0. Dividing by 0 is undefined. It doesn't work, right? So that answer 3 doesn't work. Okay? It's part of our restriction on the variables. X can't equal 3. And so if I put 3/5 in, is that right? 3/5, not 5/5. Okay. 3/5. You can test it with your, to be honest, all you really have to worry about is making the denominator 0 on these.
It's
Okay.
9 over 5.
But if you did test it, you get 1 over 3/5 minus 3. Sorry, that's a 3. And 6 times 3/5 over 3/5 squared minus 9. 3/5 is actually a nice decimal, isn't it? It's point what? 0.6. So if you really don't like that fraction, you're not rounding. It's not an approximation, it's an exact value. Right, Garrett?
Yep.
So 3/5 is 0.6 exactly. So we can plug that in and solve this, or you can put it in your calculator the way it is. Most of your calculators will deal with that nicely. Use parentheses.
So
Okay.
basically, you're just not trying to get, you're just trying to get a number that doesn't make it 0 on the bottom.
Doesn't make the denominator 0.
And also, could you just plug it into the equation that you get later? Like the
Here,
x squared minus 9 equals 6.
yeah, that should work also. As long as you didn't make a mistake from here to there.
Well, couldn't you just find the restriction right away?
You could, yep. Yep, you could. The book is suggesting that you check your answers. Sometimes we just get in the habit of getting after the homework and we forget little things like finding the restrictions on the variables. And so I just want to make sure that you go back and look at them before you say they're the answers, and make sure that they don't create denominators of 0 like this one did. Okay? All right, let's do one last example. I think it was actually number 41 I wanted to do. Um, 41, 41. 1 over b plus 1 plus 1 over b minus 1 equals 2 times, 2 over, 1 over b plus 1 plus 1 over b minus 1 equals 2 over b squared minus 1. Let me confirm I have copied that down correctly. 1 over b plus 1 plus 1 over b minus 1 equals 2 over b minus 1. B squared minus 1. Okay, so that's correct. Now this is not a proportion, is it? So it's a little bit different. So what we have to do is find the least common denominator. And again, this is how I do this. I'm not saying you have to do it my way. I'm just saying this is how I do it. This is what I find to be the easiest. I start at the first fraction, I look at the denominator, I say I need a b plus 1. I go to the second one. I need a b minus 1. I look, do I already have a b minus 1 over here? So I need to put down b minus 1. I go to the third one. B squared minus 1. Well, I don't have a b squared minus 1, but b squared minus 1 needs to be factored, right? How does that factor?
Plus 1 minus 1.
b plus 1 and b minus 1. So I need b plus 1 and b minus 1, which I already have, don't I? So I don't need them again. It would work, but it would make it messier. I don't need them again. Okay? So then I'm going to multiply every term by this denominator. This common multiple. Okay? What happens when I multiply this first term by all of that? What happens to my b plus 1? It cancels. So I'm left with 1 times b minus 1 plus, when I go to the second term, what happens to this b minus 1 when I multiply it by that? It cancels, leaving me with 1 times b plus 1. Now I know that you know that 1 times a number just is that number. But that number isn't always 1 in the homework. So I want to make sure you understand whatever that number is, you have to multiply it by this. And sometimes that number is 2 terms. Okay? You'd have to FOIL it. Alright? In this case, it's just simple number 1, makes it easier. Equals. What happens when I multiply this one by all of that?
Cancels.
Yeah, it all cancels, doesn't it? Just leaving me with a 2. Okay? I'm sorry, what's that? Let's just go ahead and do it all at the same pace instead of looking at it. Now, because it is a 1, and this is just b minus 1, right? And because this is just a 1, that's really just b plus 1. So I have b minus 1 plus b plus 1. So how many b's do I have? So I have 2b. What's negative 1 plus 1? 0. And so 2b equals 2. So when I divide by 2, b is equal to 1. So that was nice and simple, but when I go back and look, I put a 1 in here, I get 1 plus 1 is 2. That's okay, isn't it? But when I put a 1 in here, what do I get? 0. Can I divide by 0? No, so I have no answers. None at all. So we say no solution. Okay? So there's no solution on that problem. Okay, here's your assignment. You ready to copy them down? 2, 4, 12, 16, 21, 40, 46, 48, and we'll make one more ugly looking one, 52.
No, why do you do that? I don't like it.
Just to challenge you.
No, I don't need
Okay.
to challenge. I need to understand.
So the homework, let's copy this down for those at home. Yeah.
Is it
2, 4,
12, 16, 21, 40, 46,
48, wasn't it?
46 and 48.
Oh. I remember. My mind's going, I guess.
We could just do
46, 48, and 52.
Yeah.
Only 9 problems. I feel like I'm cheating you.